Buffers. What's a buffer? When you hear that word buffer, what do you think of? Did any of you watch Thomas the Tank Engine when you were growing up? Nobody will admit to it. What are the buffers on a British railroad? Do you know that? It's the barrier at the end of the train track that keeps the train from running off the track. It's a buffer. A buffer might be like a cushion to buffer you so that you don't get a bruise when you run into something. It has to do with a cushioning, right? So in chemistry, a buffer is a solution that resists pH change. And the way a buffer works is that it has significant amounts of both a weak acid and the conjugate base of that weak acid. So let's review what these things would be. A weak acid, by that we mean an acid that only ionizes a little bit. A strong acid goes completely into ions, and there's none of the original molecule left. A weak acid only ionizes a little bit. The conjugate base is what you have after the acid does what an acid does. Acids donate protons. So it gives up its proton, its hydrogen ion, and then you have the anion left, and that's the conjugate base. So in a buffer, you have significant amounts of both of these present. The weak acid can neutralize base that is added to the solution. The conjugate base can neutralize any acid that's added to the solution. So it's got everything covered. It's like, okay, you're going to hit me with acid? I've got a base, and I can neutralize that. Oh, you're going to throw base at me? I'll use my acid and neutralize that. And so it can maintain the pH when things are added. If you add a little bit of acid or a little bit of base to pure water, the pH changes dramatically. If you add it to a buffered solution, the pH will hardly change at all. This is really, really important in biological systems because the pH of a solution can greatly affect how fast a reaction occurs, whether a reaction occurs at all. It can affect whether proteins are denatured or not. A lot of chemical reactions are highly pH dependent. So the pH of your blood is very tightly buffered. Your blood will be between 7.36 and 7.40 in pH. And if it gets outside of that range, you're in trouble. Something that diabetics have to worry about is acidic ketosis, ketone acidosis, where the body produces too many ketones which react and form acid and overwhelm the buffering system of the blood and cause the pH of the blood to drop. And if you get below pH 7 in your blood, you'll die. pH 7.4 is fine, pH 7.36 is fine. Below pH 7, you're dead. Or if it gets above 7.8, you'll die. Because it messes up all the chemical reactions in your body and life can't go on. So the blood is buffered. And this happens in other types of cells as well, but buffers are really important in biological systems. So let's look at an acetic acid sodium acetate buffer system. So this is the formula for acetic acid. Acetic acid is not one of those 6 strong acids. It was hydrochloric, hydroiodic, hydrobromic, sulfuric, nitric, and perchloric acid. Those are the 6 strong acids. Any other acid is a weak acid. So when we put acetic acid into water, it ionizes a little bit. So you still have this intact acid molecule, around. If you add sodium hydroxide to this solution, the acetic acid that's present will neutralize the sodium hydroxide. If we add acid to this solution, we also have sodium acetate. This is the acetate ion. That's the conjugate base of acetic acid. We add acid to this, and the conjugate base can take that proton and neutralize the acid. Here's a picture. So this is our weak acid, the two parts of it, and here's our conjugate base. That's after it's lost the hydrogen, because that's the difference between an acid and its conjugate base. One has a hydrogen ion, one doesn't. So we've got significant amounts of the acid and the conjugate base. If we add acid to this, the conjugate base can absorb it, basically. It can neutralize it. If we add base, if we add hydroxide, the weak acid can neutralize it. So no matter what we throw at it, it can neutralize it and maintain the pH very close to what it was originally. Any questions about that?
Would baking soda be considered a buffer?
Baking soda can make a buffer, yes. So it's got, baking soda is sodium hydrogen carbonate. And so when you put that into water, the baking soda actually is amphoteric and can act as an acid or a base. So this is the sort of question that you might need to answer. Which of the following is a buffer solution? So what we're looking for here is we're looking for a weak acid and its conjugate base. So this one, H2SO4 and H2SO3. Is that a buffer? Is one of these a weak acid? Is H2SO4 a weak acid? It's on the list of strong acids. So that's not a weak acid. Is H2SO3? Well, is it an acid first? Yeah, it starts with H. It's not on the list. This is a weak acid. Okay, so we've got one component. Is this the conjugate base of that? How are they different? What's different between H2SO3 and H2SO4? It's this subscript here. Can't point. 4 and 3. The difference is in oxygen. That's not the conjugate base. A conjugate base and the acid differ by an H+, not an O. So that's not a buffer solution. So not that one. How about this? HF and NaF. Well, here we have, this is an acid and that's not an acid. Is this a strong acid? It is not a strong acid, it's a weak acid. This is a weak acid. Is this the conjugate base? Okay, so HF is the conjugate acid. When it loses a proton, what do we get? F minus, right? We take off H+, we're left with F minus. NaF, the sodium, there has to be a cation with the anion. Does this contain fluoride ion? Yes, it does. This is a soluble ionic compound. This dissolves in water and it forms sodium ions and fluoride ions. So here we have fluoride ions and we have HF, a weak acid and its conjugate base. This is a buffer. How about these two? This is an acid. Is it a strong acid or a weak acid? It's a strong acid. Is this the conjugate base? Yes. It's the conjugate base, but this is a strong acid. It has to be a weak acid. to make a buffer. Not a buffer. How about sodium chloride and sodium hydroxide? Is either of those an acid? No. It can't be a buffer. There's no acid. You have to have a weak acid and a conjugate base. Any questions?
If we're just looking at something random and we don't have to memorize is a strong or weak acid on the test.
I'll give you the list of 6 strong acids if you need that. Any other questions? Ta-da! The end of the chapter. It's the end of the last chapter. It's the end of the semester. Woohoo! I expected cheering. Nobody's brought confetti or anything? I'm excited.